So what we have here is a classic experiment. You may have seen a larger scale based on what we have discussed about drag or air friction. So what I have here, just very quickly to show you. So you can see we have a very simple experiment right here. So this is connected by electric circuit. You can see it's ball floating, it's levitating. And the reason for that, once it comes down to, there's always an opposite force. So if you're talking about Newton's third law, for every force there will be an opposing force. So in this case, the force that is dragging it downward will be the gravitational force. The force that is pushing upwards is generated by this airflow. So as long as there is a counterbalance of the force, the ball will be floating. If the gravitational force is larger than the force that is pushing outward, and what you are seeing is that it will go downward. So at the moment it's able to float because of the mass of the ball, because of the airflow from the bottom pushing outward, and that allows the ball to levitate. So think about, is there any other Newton's third law that applies to your everyday life? Some people may be thinking, how about an aeroplane? Quite a similar. So of course, aeroplane, there's also aerodynamics as well of the plane design, but if you are thinking about what allows a particular device, a particular equipment, or in that spacecraft to be able to float, you must have that opposite force. As long as the upward force is stronger than the downward force, it allows it to fly.